Hi, in this lesson, you will learn about multivariable linear regression. We've learned that the line of best fit is a line that best expresses the relationship between all data points and is capable of making predictions. We've also learned that linear models are only useful in data that is correlated. In our example here, movie ticket sales have a direct relationship with the popcorn sales and can be used to help predict how much popcorn is sold at the movie theater. But what if there's other variables that can explain this relationship? In other words, what if there's other factors that can also play a role in how much popcorn is sold at the movie theater? For example, the time of year might have an impact on popcorn sales, or the number of superhero movies that are in theaters, or even the average age of customers that attend the movie theater. Each of these relationships may turn out to have a linear or semi-linear relationship and have an impact on popcorn sales. If this is the case, then how can we express the relationship between all these factors? We can evaluate the relationship between all these independent variables through multivariable linear regression. Multivariable linear regression is a statistical analysis that determines the relationship between multiple independent variables and expresses it as a linear equation. In the examples that we've looked at so far, the linear equation has been a simple y equals mx plus b equation, where the value of y is impacted by the value of x, or the independent variable. For multilinear regression, the value of y is impacted by all of the independent variables. In this equation, each x variable represents a different independent variable. You'll also notice that each variable has its own slope coefficient. This means that the weight or importance of each variable is different. We can also use Sklearn to create multivariable linear regression models, the same way that we did with the simple linear regression. Here's an example. You may recall that the first parameter in the fit function was supposed to be a 2D array. This is so that multiple independent variables can be input into the model. Here we can create a 2D array that includes each independent variable as a separate list item. We then pass that 2D array to the regression object, and a model is created as a result. Predictions, coefficients, and intercepts work the same way as well. Now that you've learned about multivariable linear regression, in the next video, you will learn about gradient descent.